Hi everyone, so glad you could join us. Today, grade 11s, we are looking at finance. And when we talk about finance, we should be thinking about things like compound increase, compound decrease, and of course, timelines are a big thing. So our topic today in finance, growth, and decay, we're going to be looking at summarizing some of the big concepts, the big ideas that you dealt with in grade 11 financial maths, and that is looking at compound increase. And then a big thing that helps you when you're dealing with these financial maths calculations is timelines. All right, so let's just remind ourselves what compound increase is and what the formula looks like. Basically, when we talk about compound interest, remember we get simple interest and we get compound interest. Simple interest is exactly what it sounds like. It's simple, okay? Interest is only added on the original amount that was invested. However, in compound interest, interest is calculated on the original amount that was invested or in fact borrowed, and on the interest that has already accumulated. So it gives us this idea of earning interest on interest, and this is what makes your money grow faster. If you're thinking about saving and investing, we use compound interest because money grows faster because we earn interest on the actual interest that we've already accumulated. The formula we use for compound increase is A is equal to P times 1 plus I to the power of N. Let's discuss the variables. A is called the accumulated or final amount. P is the principal or the initial amount invested. I is, of course, the interest rate, and this is given as a percentage divided by 100. So we put the rate in there but after we've divided by 100, and N is our time period. So it depends on how often our compounding occurs, what will happen to N and what will happen to the interest rate. So talking about how often compounding occurs, we get this idea of a compounding period. Now remember we said that interest is calculated on the principal amount plus interest, right? So a compound, and when we talk about different compounding periods, what really happens is that interest can be compounded more often than just annually. It can happen at any regular time period in the year. So it can be monthly, and it basically tells us how many times interest is charged or added or earned in a year. So if we were looking at a monthly interest rate, then that means each month we are getting interest added to our investment if we're talking about an investment. All right, so some of the common periods that you come across is we get compounding that can be daily, weekly, monthly, quarterly, half yearly. You've seen things like that, semi-annually or biannually, which is 2 times a year. Annually, of course, where it's just once a year. Biennially, now this is a new one. Some of you may have not seen this in your questions as yet, but if you ever see this word biennial, it means that compounding happens every 2 years. All right. You can even get compound growth continuously. It's not a formula that you use in grade 12 maths, but certainly if you were to continue studying, you will learn about continuous compounding. Now, regardless of the compounding period, the interest rate is generally stated as the annual rate, which we call the nominal rate. It's in name only, okay? When the compounding period is not annual, however, we need to adjust the compound interest formula, and you would have seen this. This is where we changed N by multiplying by the number of times compounding occurs, and then we divide I by the number of times that compounding occurs. So we change the compound interest formula to reflect any change in the compounding period. So let's look at an example to make this clearer. So say we've got 9,000 Rand, and this is invested at 9% per annum. So you see it's a stated interest rate, 9% per annum, but it's compounded monthly. So that tells me straight away, every month I'm getting interest added onto this investment. They ask us to calculate the amount after 5 years. So some of the things that we need to remember that are going to be affected in our formula. Because we've got monthly compounding, that means how many times in a single year are we going to get interest added on? Every month, right? And how many months are there in a year? There are 12. So therefore, in a single year, of 12 months, you get interest added on 12 times. So if we were just looking at a year, then what we would do is we would take 1 and times it by 12 if n was 1. In this case, we are looking at n being 5. So therefore, our number of compounding periods now would be 5 times 12. So this m represents your compounding period, which is 12. So m is equal to 12. What I like to do when I'm faced with a question like this is I like to write down the values that I've been given. I've been given A. I've been given, I've been given P. We are asked to find A. So P is the initial amount that we invest. I've been given that P is 9,000. And of course, we're looking for the amount, which is the accumulated amount at the end of 5 years. So I've been given P. I've been given that my interest rate is 9% per annum compounded monthly. So I is 0,09, and then we'll divide it by 12 to reflect the compounding. And n is actually going to be not just 5 years, but 5 times 12 to reflect the compounding, which is 60. So once we've made a little list like this on the side, we can easily then substitute values into our formula. So we'll say P is 9,000 times 1 plus I, which is 0.09 over 12, all to the power of 60. Once you get to this point here, it's just a simple matter of substituting values into your calculator, multiplying out, and you will get that your final accumulated amount is 14,000 Rand and 91 cents. So the final answer is not the only important thing here. What's important is the way we got to this answer. How did we get to this answer? We had to remember that we needed to multiply n by our number of compounding, the number of times compounding took place. So we needed to multiply n by 12. We also needed to divide our interest rate by 12. Okay, so when we do that, we will then get into a position where we've got an interest rate that matches the number of times compounding happens. So if we multiply n by 12, we've got to remember to also divide I by 12. So those are some of the important concepts that we learn when we deal with compound interest. Now, the amount of compound interest earned on an investment or paid for a loan obviously depends on the frequency of compounding. Like we said, it can be annual, it can be monthly, quarterly, etc., etc. What we need to remember is that the higher the number of compounding interests, compounding periods, the greater the compound interest is. So if you are getting interest that is compounded quarterly, which is 4 times in a year, versus interest that is compounded monthly, in which one are you going to make more money? It'll be slight, but in which one will you make more money? In the one that's compounded more often. So you would make more money with monthly compounding versus quarterly compounding. So that's all we're saying here. The higher the number of compounding periods, the greater the compound interest at the end. And all you can see in this little table is just rewriting what I've already spoken to you about before. If the compounding period is monthly, then the value of M will be 12. If the period is half yearly, which is the same as biannual, then M will be 2. Quarterly, M is 4. Weekly, M is 52. Daily, 365. And biannual is a half. All right, guys, so those are important things that we need to remember, the value of M, especially when we are looking at different types of compound interest questions. Now, remember, when we talk about compound interest, there was this thing also called simple interest. So we haven't really discussed simple interest here, but remember, simple interest has a very simple formula as well. So with simple interest, we have the formula, let's call that up. A is equal to P into 1 plus I times N. So there's no power here. So that is your formula for simple interest. It has a simple formula. And the thing all about simple interest is that we don't get as much money out as we do if we're investing using compound interest. So you'll find that simple interest is not really used a lot. You also don't see it a lot in your exam questions. Generally, when we're talking about simple interest, we look at hire purchase agreements, which in the real world, there aren't that many. It does happen, of course. So, you can go and buy a TV and you can get it on a hire purchase agreement in certain stores, but many stores normally don't offer hire purchase agreements. Some of them still do, however. If they offer you a hire purchase agreement, it will be based on simple interest, not compound interest. So the focus of today's lesson is really all about compound interest, because that's the one that you're going to see more often in exams, and that's the one that you've got to know really well for the real world. And remember, when we talk about compound increase, it's not only in money terms. You can also think about the rate of growth of bacteria, and that's where you could use the compound growth formula. And certainly also, if you think about population growth, we could use the compound growth formula to model even population growth. Very, very important concept. Let's quickly take a break. When we come back, we'll talk about timelines. Hi everyone, so today what we are doing is we are looking at a summary of some of the key concepts we learned in grade 11 about financial maths. One of the big ideas is, of course, compound increase. And another thing that we use quite often is something called timelines. Timelines are super important because it helps us to answer questions, hopefully correctly, in financial maths. Let's have a look at what a timeline looks like. So a timeline is really useful for representing information when we have changes in any of the variables, whether it be A, P, I, or N, during the period of the investments or the loan. So a timeline, generally what it looks like is it's just a straight line that we draw as a rough sketch. So it doesn't have to be using a ruler or anything like this. It's just a straight line where we represent information that they give us on this line. So say, for example, I'm investing at an amount at now times 0. So we call the present time times 0. And so let's just say we're putting X amount in at time 0. And then we've got several things that can happen. So let's say T1 time 2 times T1 time 1, T2 time 2, time 3, and time 4. So these 1, 2, 3, 4s, they can represent years or months. It depends on the question and it depends on the information that's given to you. So in my case, say I've got X amount invested for 4 years. Then those 1, 2, 3, 4 represents years. But if we were talking about monthly, then we could certainly represent a timeline to show monthly intervals as well. So where it's useful is, say that we took this X rand, we put it in, but then say in 2 years' time, we decide, okay, I'm going to now put in 500 rand. I want to add an amount to a savings account. So at time 2, I then put in 500 rand. So on the timeline, I will represent that as 500 rand going in. Say then, and in 3 years' time, we decide, okay, well, we really need this money to come out of the account because I've got a big purchase that I need to make. I can then say, well, let's say we take out 1,000 rand at year 3, obviously depending on what's in your account by that time. So you can represent that either using brackets or a different color or something to show yourself that it's a withdrawal. So what I would like to do when I draw a timeline, certainly you can use different colors or just use pluses or minuses. So use a plus sign to show money going in, use a minus sign to show money going out, or you can use brackets to show money going out. Other things that could happen along this period of time when we're putting our money into this account, perhaps you started with an interest rate that was compounded monthly, so you might have monthly compounding at this point. And then suddenly, 3 years later, the bank decides, okay, it's changing its interest rate and the compounding becomes quarterly. So you can show that on your timeline, and this will then help you to keep track of all the goings-ons in this account. So you can then see, okay, at time 3 this happened, at time 2 this happened, and you can reflect all of that information in a nice short manner using our compound interest formula we can show all of this information that's happening on a timeline quite nicely using the compound interest formula. And remember, what the interest rate does is it helps you to move to different points along your timeline. So if you wanted to get from time 0 to time 2, you would need to multiply by your interest rate to get there. And this is why it's important that your timeline not only reflects what's been put into the account or what's been taken out, it also needs to reflect your interest rates. All right. And the best way to look at using a timeline is to look at an example. So they say 2,800 Rand, so we mark this off as P, is invested in a savings account, and 12 months later, a further 1,400 Rand is deposited into the account. So we see that this is money going in, okay? They want us to calculate the total amount saved, and make sure you read to the end of the question before you start marking information on your timeline. Calculate the total amount saved by the end of the second year if the interest rate is 4.85% compounded quarterly for the first year, and then it's adjusted to 5.9% compounded monthly for the second year. So we see that we've got changing interest rates during this investment, but we've also got extra money coming in. So just thinking about all of this can seem confusing. So let's put this information into a timeline and see if it makes more sense. All right, so let's draw our timeline. We're starting now at time 0, and we're putting in 2,800 Rand. And you can put a plus sign there if you want to remind yourself it's money going in. 12 months later, which is the same as saying a year. Now guys, the one thing you must remember on your timeline is don't confuse periods. So don't change to months and years on the same timeline. You will make a huge mistake. So we're not going to write T12 here. We're going to put in T1 because 12 months is a year. So 12 months later at time 1, a further 1,400 is deposited. Because it's going into the account, we can put a plus sign to show that it's going in. Calculate total amount at the end of the second year. If the interest rates, and now we've got our changing interest rates, we've got 4.85% compounded quarterly for the first year. So from time 0 to time 1, we had 0.0485 our interest rate, and we're going to compound quarterly, which means divide by 4. Why are we dividing by 4? Because remember here, compounding quarterly, it means interest is added 4 times a year. We need to adjust the compound interest formula to reflect this. How do we adjust it? We divide I by the number of compounding periods, and we multiply N by the number of compounding periods. The interest rate is then from time 1 to time 2, it's compounded monthly, and it changes to 5.9%. It's increased. So 0.059 divided by 12, because interest is now compounded monthly. So to get to the end of this timeline, which is at time 2, I need to take this 2,800 Rand, move it along to time 1, at this interest rate of 4.85% compounded quarterly. I then need to add in the 1,400 Rand at this point in time. Once I've done that, I then start moving again. And how do I move? I need to multiply by this new interest rate, which is 0.059 divided by 12 to take into account the compounding. And that happens for a further period of how many? Well, if we're going from time 1 to time 2, so that's 1 year, and we've got compounding monthly, so then we're going to times by 12. All right, so let's see nicely how this is all done. So we can see on our timeline, we put our 2,800 in at time 1, we put in 1,400. You can see that we're representing the change in interest rates in each period. All right, so here, this is the interest rate that's effective there, and then we've got another one from time 1 to time 2. Now, how do we get the money all the way to time 2? This is where we use our formula. So this formula that we see here is A is equal to P times 1 plus I to the power of N. Okay, so the way I like to do this, guys, I do it all together in one sum. You can split it up. Now, what I mean by split it up is you can take the 2,800 Rand and take it all the way to time 2, and then take the 1,400 Rand and add it onto the 2,800 Rand by taking 1,400 Rand to the end of time 2 as well. Basically, you can only add amounts at the same point in time. So I cannot take 2,800 added to 1,400 straight away without using my interest rate, okay? So therefore, to get from here, time 0 to time 1, all I do is I say 2,800 times by 1 plus 0.0485 divided by 4 to represent the quarterly. In that time, we've got 4 compounding periods, so 1 times 4 raised to the power of 4. When I get to this point at time 1, I then add the 1,400 Rand into the account. I then find that amount, so I know that's the total amount at time 1, and I multiply that by the new interest rate to take me from time 1 to time 2. So I multiply by 1 plus 0.059 divided by 12. We raise that to the power of 12 to reflect your monthly compounding. You put all of that into the calculator and prove for yourselves that the final amount in the account will be 4,601 Rand and 30 cents. Timelines are super important, and you need to be using those in order to answer your financial maths questions. Very quickly, let's talk about reducing balance depreciation, or as we call it, compound decrease. What happens in that case is when we're using reducing balance, which is A is equal to P, looks very similar to compound increase, except for the plus changes to a minus. 1 minus I to the power of N. So what happens with reducing balance or compound depreciations? We have higher depreciation expense in the earlier years of ownership. It's based on the asset's previous value, and every period the depreciation will be a percentage of the reduced value of the asset. So this is the whole idea of compound interest, but now it's compound decrease that's coming into play, where we're taking away smaller amounts each time. The value of the asset will depreciate by smaller amounts each time, and at the end of the period, though, the asset does not reduce to zero value. What is left is what we call scrap value. So it never really depreciates to zero. The value that you're left with of your asset is something that you can sell off for scrap. So for example, if a company has a car, it will have some value at the end, whether you sell the wipers and then the lights separately and then the seat covers or whatever, you will still have some value that you can get back out of that car. So just looking at the formula for reducing balance depreciation, we said it looks very similar to the compound interest formula, except for we have a minus to indicate that we are looking at compound decrease. So A in this case is the book value or the scrap value. P is your initial or principal value. I is the depreciation rate, okay, it's divided by 100, so we show the depreciation rate, and the period is again given in years. All right, guys. That is all we have time for. Thank you so much for joining us, and hopefully any of your issues have been cleared up. We see you next time.